Numericals and transformer. The primary coil of an ideal step-up transformer has 100 turns and transformation ratio is also 100. The input voltage and power are respectively 220 volt and 1100 watt. Calculate number of turns in secondary, current in primary, voltage across secondary, current in secondary, and power in secondary. So let's evaluate. So we are given transformation ratio, that is K, which is equal to N2 upon N1. That is given as 100. From here, we can get N2. So N2 equal to N1 times 100. So number of turns in primary is given as 100 and transformation ratio is 100. So we will get 10,000. Now, we can find voltage in secondary. So E2 upon E1 or V2 upon V1 is equal to N2 upon N1 or transformation ratio. So here V2 will be equal to V1 times N2 upon N1. And the V1 is given as 220 volt, 220 into transformation ratio is 100. So from where we will get 20,000 volt. Next point is to find current in primary. So we know power equal to VI or EI. So P1 equal to V1 times I1. So from here we can get I1 equal to P1 divided by V1. P1 is given as 1100 watt divided by V1 is 220. So from here we get 5 ampere. Now we can get I2 also. So since input power equal to output power, here this is ideal transformer. So we can say V1 I1 must be equal to V2 I2. So we can write it. V1 I1 is given as 1100 and V2 we have found as 22,000 I2. So from where we get I2 equal to 0.05 ampere. So what all values? Next point. The question is the number of turns in the primary of an ideal transformer is 200. Means N1 is given as 200 and in the secondary N2 is given as 1000. If the input power in primary means P1 equal to given as 10,000 watt because 10 kilowatt and V1 is given as 200 volt, then we have to find out V2 and current in the primary. So P equal to VI. So from here P1 equal to V1 I1. So I1 equal to P1 upon V1. P1 is given. Your power in input is 10 kilowatt divided by voltage is 200. So we will cancel out and this will be 50 ampere. Now current in primary we have got output voltage. So here output voltage can be found by formula V2 upon V1 equal to N2 upon N1, that is transformation ratio. So V2 equal to N2 upon N1. N2 is 1000, N1 is 200 into V1 is given as 200 volt. From we get 1000. Now let's go to next question. Calculate the current drawn by primary of a transformer which steps down 200 volt to 20 volt to operate a device of resistance 20 ohm take the efficiency of 80%. So here we are given E1 as with the drawn by primary step down 200 volt to 20 volt. It means E1 equal to 200 and E2 equal to 20. Eta is given as 80%, that is 0.8. Now E2 equal to I2 R2. So if E2 is 20 and I2 is to be found and the resistance of the device is 20 ohm, so we can get I2 equal to 1 ampere. Now we apply the formula of efficiency. Eta is given by output power divided by input power. That is 0.8 equals E2 I2 divided by E1 I1. So 8 by 10 equal to 80% means 0.8 equal to 20 times I2 is 1 ampere divided by E1 is 200 volt into I1 is to be found from where we get I1 equal to 0.125 ampere. Now let's go to next question. This is a very good question for CSE board. So here length of the wire is a town situated 20 km away from a power plant generating power at 440 volt requires 600 kilowatt of electric power at 200 volt. The resistance of two wire lines carrying power is 0.4 ohm per kilometer. The town gets power from the line through a 3000 to 420 volt step down transformer at a substation in the town. So here, since there are two wires and the total length is 20 kilometer, so we can count here. This is not 20 kilowatt, this is 20 kilometer. So resistance of two wires equal to 20 kilometer first wire, 20 kilometer second wire, so 20 and 20 equal to 40 kilometer. So 40 and 0.4 ohm per kilometer. So 40 multiplied by 0.4, that will give 16 ohm. Now IRMS we can find. So power is 600 kilowatt and supply is 3000 volt. So 600 into 10 to the power 3 divided by 3000. So that will give 200 ampere. Keep in mind that whenever transmission is done, it is done at high voltage. So that is why 3000 volt is taken, not this. This is the voltage that the substation receives. Now, so we have got IRMS. Now power loss, let's check. So power loss is equal to IRMS squared times the resistance of the wires. So IRMS is 200 squared into resistance of the wire is 16. So it will come to be, that is 640 into 10 to the power 3 watt or 640 kilowatt. Now power loss we have got, and we have to find out the total power. So the substation requires 600 kilowatt and power loss in the way 640. So we can say power supplied must be equal to need or demand plus loss. So need is 600 kilowatt plus loss is 640 kilowatt. So that will be 1240 kilowatt. This is our answer. Thank you for watching.